Hi there, I'm Joe Whittaker. Everybody hear me okay? I'm going to be talking about mammals, and I'm going to try to start off with a kind of a broad approach to mammals and then kind of get down a little bit closer to home. So, all right, well, mammals, first off, we've been looking at insects. Mammals are going to have fur, so you're going to see fur will be the first thing you notice about mammals. I think we're all pretty familiar with those. They're also endothermic. They generate their own body heat, which is going to give them some challenges in the face of changing climate as well, in terms of being able to control their temperature. There's 34 families of mammals, and 423 approximately species, so much less diverse than insects, but still a nice diversity. And this recent study came out that was looking at mammals in terms of if climate continues to change the way we think it is changing and will change, continue to change, are mammals going to be able to respond to it? Are they going to be able to keep pace with the changing climate? Are they going to be able to move more northerly to stay in the temperature ranges they need? And what the study indicated is quite a few species are going to have trouble. Anybody below this is not going to be able to keep pace with the change in temperature. Anyone above it probably will or may be able to. You'll notice down here there's a lot of rodents, so the squirrels that we were talking about may or may not be able to make it. Insectivores and primates are ones that we're particularly concerned with in terms of not being able to make it. The study also looked at human land use, and what they found was there was a certain group, the ones in red, are not going to be able to keep pace. The ones that are in the blue could keep pace, but the changes in human land use are going to prevent them from being able to keep pace. So while they could actually be able to do it, they're not going to be able to move through habitats to get to appropriate habitat for them to continue living. And then the ones in the kind of pinkish areas are kind of in trouble either way. They're not going to be able to keep pace, and they wouldn't be able to move through the habitats that are present. Now, if we get to Minnesota and start looking at Minnesota, Minnesota has a pretty diverse mammal fauna. So there's a few states around us that have more mammals. Most of those have mountains or other structures that enable them to have a higher diversity. But a lot of the other states right around us don't have the same diversity we do. Minnesota's fairly special that way. And part of that is because of the different habitats we have here. Now, in the face of changing climate, these three biomes that meet here in Minnesota may or may not still be present. They may change, distributions may change, so that certainly could affect what mammals we find here in Minnesota later. So that could certainly change. Minnesota's been ranked as the third fastest warming state in the Union, which is a little frightening with that too, in terms of trying to keep pace with what's going on in the state. And you can see pretty easily here the trend for the temperature in the state to be going up. And again, it's noisy data. And this noisy data then tends to make it possible for people to question the data. But I think you can see there's a pretty good trend in there, and I think most of us are here because we tend to think that that is there. Oops, a little fast there. I want to start talking about one of the more iconic species in the state, of mammals anyway, and this is the moose. The moose is considered, again, a boreal species. It reaches sort of its southerly range here in Minnesota, and again, this is one that you tend to want to see when you're up in the Northwoods. It's one you want to think about and knows here. I remember back in 1989 seeing these out on the prairie, not far from here when I was taking a course at the Idaho Biological Station. But again, they do sort of reach their southerly range here in Minnesota. They don't go much further south. And it's been documented pretty well in the state now that the population's in a really rapid decline. Lake Agassiz National Wildlife Refuge used to be a great place to see moose. You could go there and see them pretty reliably. But the population's dropped off, fairly precipitously, and you can see it's dropping off to the point where they're having trouble finding moose. And it's also occurring other places in the state as well, so not just that one refuge, but other places too. The population's dropping off very, very quickly. And you start asking why. And one of the things you can look at is, again, climate change. You can look at changes in temperature, increase in winter and increase in summer temperatures, and that may be related. You also look at the population decline relative to the temperature changes. And again, it looks pretty strong that there's something going on with temperature in moose. And then you get the critics who say, but I don't understand why temperature is going to knock the moose out. Why is temperature going to do this to moose? Why can't moose survive this? It's got to be something else. And there is, for us biologists, no smoking gun. There's not a really good piece of evidence to say, here it is what's doing it. At least there hasn't been, and that's something people are working on. But again, it's not as easy as watching an episode of CSI where you can find the answer, solve it, and get everything done. So one of the big questions, or one of the big comments that you see a lot in discussions is it's got to be the predators. We have a high wolf population. Obviously the wolves are killing off the moose. It has nothing to do with climate, right? People have probably heard that one before. That's one of the reasons why they're talking about it, or a lot of people advocated the wolf hunt. But if you look at the actual data, or what we're seeing, What you're seeing is most of them are dying of unknown causes, the vast majority. You're seeing predation in 6%. These aren't potentially predation, these are just literally dropping dead and we don't know why. And by the time we get to them, you're not seeing good data on this. The DNR is trying to get a number of moose collared so they can follow them through and get to them right after they died, so they can try to figure out what's going on and what is actually killing them. It's very much a mystery. They appear to be in more or less decent condition and are pretty much dropping, and we're not sure why. Elsewhere in the state, they've looked at and seen disease and starvation. Unknown cause, again, is very high. Liver flukes has recently come out much higher, and brainworm is another one that's come up. Some of these can be tied to global warming. So, question? I'll get you in a minute. So if we look at brainworm, which is kind of an interesting one, this brainworm affects white-tailed deer. It doesn't kill white-tailed deer, and it does pretty well in the white-tailed deer. The problem is when it gets into a moose, it does tend to kill off the moose. So moose can't survive this brainworm anywhere near as well. What happens is, and whether climate change comes into this, and the idea of warming temperatures, warmer and wetter summers, or warmer and wetter weather in general, tends to be really good for the snails. So the snails increase as the vector, taking the parasite from them as sort of an intermediate host to the definitive host. And in this case, it's a dead end. If they get into the moose, they don't reproduce, and the moose winds up dying. And the white-tailed deer functions fairly well, but in the moose it does not. Oops, went a little fast there. This is kind of gross, but this is the liver fluke. The liver fluke, so right here, this one, again, as I showed you a minute ago, has increased dramatically and is being blamed for a lot of the deaths on the moose. The liver fluke itself doesn't kill them. What it does do is it reduces their condition and can cause infection. This is showing an infection from a liver that's been taken out. The infection is the thing that actually kills the moose. The liver fluke then causing the infection. So it's not a direct relationship. Again, it's kind of disjointed. So this fluke, again, has an intermediate phase, or the intermediate host is going to be a snail. So anything increasing the snail population is going to increase transmission of the fluke. And that's apparently what's doing this in terms of the moose. Another thing that seems to be having a big impact is ticks. As the winter temperatures are less severe, we're not seeing the die-offs in ticks as normal. When you have a high load of ticks on the moose, it tends to cause hair loss, tends to mess up their ability to thermoregulate, and it also, they've shown some of the really high tick populations on moose has caused them to actually become anemic. So that is also affecting their health and survivability. And then I want to move to another species, a little more near and dear to my heart, and one that we have probably less good data on in terms of what's going on, but I wanted to look at the white-footed mouse and the deer mouse. Both these mice occur in the state. They're extremely similar, and I've got some students working on better ways to tell the two apart. They're very hard to tell apart, but we do know historically these guys seem to be doing quite well with the white-footed mouse, but these guys seem to be disappearing now in other states. So their ranges have overlapped, and they've overlapped for a long period of time, and they've been able to coexist and coexist well. But recently we've been seeing some kind of trends indicating the deer mouse are dropping out and being lost. So I'll go through this really quickly. In looking at historical data, we have a prediction of how many mice we think should be captured when you go back to the same sites. And what we're finding is, here you'll notice, basically 0.02%. So the mice have dropped down, the deer mice are disappearing from Illinois, whereas the white-footed mouse is increasing rather greatly, 194%. And this is in Michigan. We're seeing the deer mouse also dropping out as white-footed mice sort of suddenly appear around 1987. They seem to then be ecologically replacing the deer mouse, where they formerly coexisted. Oops, jumped ahead there. And you can see in this one as well, the white-footed mouse just sort of appears and seems to be occupying new habitats and then taking over, again, ecologically replacing the deer mouse. Well, part of this is probably related to land use changes. Deer mice are less able to tolerate some of these land use changes than the white-footed mouse are, but it also probably, and again, we don't have good data on this, this is something we're just getting around to, is trying to figure out the role of climate in this swap over as well. So why do we care if we lose deer mice and we have white-footed mice? Well, white-footed mice, one of the things they do is carry Lyme disease. They tend to be one of the species that serves as a reservoir for Lyme disease so it can jump into humans. So what happens is, basically the tick bites the mice first, and then after basically picking up the parasite, the bacterium can then deliver it to larger vertebrates, including humans. And that tends to be what happens. They pick it up from mice or birds first. So what we're seeing, and here's actually a white-footed mouse with a tick. You can see a number of ticks on there, at least 4, just in that picture. And that's one we caught over by Itasca State Park. And here we can see again the white-footed mouse range. And here in Minnesota, we now have counties directly next to us that have extremely high risk areas for Lyme disease. When I was here in 1989 as a student up at the Itasca Biological Station, I never saw a black-legged or deer tick. It was all wood ticks. Now when I go over there, you see them all over the place, and you pick a lot of them off you. We can see too, if you think about those graphs I showed you with temperature, you can see this nice little increase in the cases of Lyme disease kind of related to it, not potentially related to it anyway, I can't say definitely they are, but potentially related to it. Again, if you don't get die-offs of the ticks have higher survival, you're going to wind up seeing, again, increased populations of ticks, increased incidence of disease. And we also see this with anaplasmosis, similar pattern. And babesiosis, I always mispronounce that one, but again, we get these same diseases, or these diseases coming up, and again, some concern with the number of ticks not dying off during the winter, doing quite well in the wintertime. And I think that's all I really wanted to say about that. I was hoping to get to bears, but I think I'm out of time, so if you have any questions, I may have time to answer one or two. It's what we've guessed. We don't know for sure. We're not sure what the swap over is with those. There have been some generalized observations that it looks like areas that are more disturbed, whether that's disturbed through logging, disturbed through agriculture, road building. You tend to see the deer mice disappear from those areas first. And here in Minnesota, we're not seeing the deer mice disappearing. We're not sure if we're seeing deer mice disappearing, I guess is what I should say. Whereas we've seen it in Wisconsin, we've seen it in Michigan, we've seen it in Illinois. So we're sort of waiting to see what's going to happen with those at this point. The main problem is not being able to tell those two species apart very well, and that's something we've been working on here with some of the students. But it's intriguing what's going on in the other states to see if we're going to see the same pattern here. If it is land use, some of the areas we're working in here are not undergoing some of the land use changes that they were seeing in Wisconsin and Michigan. So if it does start happening here, it would probably be more climate related in some of the areas we're looking. But again, we don't really know. We just know it's happening, and it's one of those things you perceive it and suddenly try to start scrambling to figure out what's going on. So, sure. Other questions? All right. Thanks.